Hi, everybody. Welcome to Self Check 3.4, and we're going to be working on exercise 2 on this assignment. So let's go ahead and read through the question here. So a retailer anticipates selling 5,400 units of its product at a uniform rate over the next year. Each time the retailer places an order for X units, it is charged a flat fee of $75. Okay. And so carrying costs are $36 per unit. So we have a couple questions here. How many times should the retailer reorder each year? What should the lot size be to minimize inventory costs? And what is a minimum inventory cost? And notably, we want to use the EOQ formula to obtain these answers. Okay, so I've written out the EOQ formula that could be also found in our notes, but here it is available as well. It's just X meaning lot size, right? Lot size equals the square root of 2 times our cost per order times our number of units sold divided by carrying cost per unit. So what I want to do is divide up these questions one by one. So the first thing we got to find here is our lot size. So what I'll do here is this second question, what should the lot size be, is going to be our first one. How many times should we reorder should be our second, and then the total inventory cost at a minimum is our last one. So we want to find our lot size first. So we're going to use the EOQ formula to streamline this process. So our cost per order is stated in the question. It's just going to be $75. So let's go ahead and write out all that we know. So cost per order equals $75. And then number of units sold during that time, it says in the beginning is 5,400. So number of units sold is going to be 5,400, sorry, 5,400. And carrying cost is going to be stated $36. Okay, so let's go ahead and put all this into our EOQ formula. So we'll have X equals 2 times cost per order, that's 75, and number of units sold, that's 5,400, all over carrying cost, and that is 36. And that's all under square root. And so this becomes square root of 2 times 75 times 5,400 is 81 or 810,000 over 36, which is square root of 22500. We divide that by 36, and this square root of 225, I'm sorry, 22,500 is 150. So X equals 150 is the lot size using this formula. Okay, great. So that answers question one, right? So I'll say question one, that's our lot size. So now question two is stating how many times should the retailer reorder each year? So that's us cutting up our number of units by our lot size to minimize that cost. So I'll say step two for reorder is number of units sold divided by lot size. Right, this is also something in that reordering formula from our notes, but it's just a way to cut this up to minimize its cost. So a number of units sold is 5,400. So 5,400 divided by our lot size that we just found to be 150. And if we cut that up by 150s, it should be 36 orders that we would like to make. So this is really just 36 orders of size 150, our lot size. Okay, so that's how many times we'd want to reorder a year to minimize that cost. Okay, so that is step two. All right, so let's cut that off. So the last question is asking, what is the minimum inventory cost? So this is where we still need to develop that inventory cost function and plug in our lot size, the minimum cost. So we still need to create this inventory cost function. So recall that, for minimum inventory cost, okay, remember that it's C of X equals H of X, that holding or carrying cost, plus the reorder cost or the reordering. So off to the side here, recall that that's this carrying cost is carrying cost times our lot size divided by 2. And we have our carrying cost right here. So this ends up being 36 times x over 2, which is 36 over 2x, which is 18x. So h of x equals 18x. Okay, so that's our carrying cost. So now what about our reordering? So reordering is cost per order times number of units sold divided by our lot size. Let me scoot this over a bit. And rewrite this. So cost per order times number of units sold divided by our lot size X. Okay, so let's go plug in what we know. So cost per order that we found was $75. So 75 times number of units sold, and that is that 5,400. So 5,400 divided by X. And so let's go ahead and simplify this out. So 75 times 5,400 is 405,000 divided by X. So this is our reorder. Okay, so this is our off to the side work. So this means our inventory cost function is h of x, so 18x plus 405,000 over x. Okay, so that is our minimum inventory cost function. So luckily, using the EOQ formula, we already have our lot size, so we don't need to take a derivative and find a critical value, set it equal to 0, etc., right? We already have this lot size that's going to minimize inventory cost. So what I can do is just plug this 150 into this minimum inventory cost function that we just found and get that minimum cost. So let's go ahead and do that. So I have C of 150. So this will be 18 times 150 plus 405,000 divided by 150. And this ends up being 18 times 150 is 2,700. 405,000 divided by 150 is also 2,700, which ends up being 5,400. So this means the total, I'm sorry, the minimum inventory cost is $5,400. Okay, so that answers all three questions, but let's go ahead and put this all together in a nice, clean statement. So this means that, as a final, use a different color. So final answer, the company should reorder. How many times should we reorder? 36 times each year with a lot size of how much? 150 to have a minimum inventory cost of $5,400 that we just found. So, okay, that is summing up all of our findings. But here's each question individually for each part. But this is using the EOQ formula to kind of streamline the process instead of the long-winded one we did prior. But that's it for this self-check example, and I'll see you next time. Thank you. Bye.